Okay, welcome back, grade 11s. Today we're going to learn about our fourth and final formula that relates to quadratics. So, we know the standard form of the equation. You have that memorized by now. ax squared plus bx plus c is equal to 0. Or sometimes we write y here, or sometimes we write f of x if we're using function notation. Okay, and you know what the A does, right? That's the concavity. And you know that C, the constant term at the end, is the y-intercept. Okay, now today we're going to learn the quadratic formula. This is the quadratic formula. Please record it in full and make sure all the signs are right in your notes. We use the quadratic formula to find the answers. In the past, we have factored to find the values of x. The quadratic formula is very handy when we can't factor, because if we put everything into the quadratic formula, it gives us the value for x, the answers that we're looking for, the places where the graph will cross the x-axis. So it is x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. The a is the same a that's in standard form. And you can see b also, negative b and b squared right there. And c comes into play right there. So we're going to start in standard form so we can pick out our a, b, and c values. Another thing to note before we move on is that underneath the square root sign, we are not allowed to have a negative value yet in Math 11. Okay, so we're never going to have a negative value. If perchance that is negative, that means the roots don't exist. Before we move on with the quadratic formula, let's recap how we can solve equations already, what we've already learned in this unit. So the first way we solved is just simply by graphing. Remember doing that? You set up a table of values and you graphed it, or you used Desmos to graph. And then the answer came, when we graphed it, it came from the x-intercepts. We find the x-intercepts. Okay, hopefully you can recall doing that. That was 7.2 and 7.3. Okay, then in 7.4 we talked about factoring. And we were able to factor the quadratic equation. And then, how did we find the answer there? We find the x values that make each factor equal to 0. And those were our answers. The third way, we used the vertex graphing formula. This formula helped us to easily see the vertex. It didn't give us exact answers for our x-intercepts, although we could tell at a glance whether there was 0 answers, 1 answer, or 2 answers, or x-intercepts. So today we're going to learn the fourth way using our quadratic formula. Okay, flip the page and let's do an example. Our first step is always going to be to put the equation into standard form so we can find the a, b, and c values. So here it's a positive 7x. I need to subtract 7x from both sides, which will give us 0 on the right. So then I have 6x squared minus 7x, let's put it in the right order, equals 0. Now we can easily find our a, which you are good at this already, our b, don't forget the negative, and the c, which also is a negative 3. Now, we're going to take those three values and put them into our quadratic formula. In order to avoid errors, it's a very good idea to write your formula out before starting, just like you would in a physical science class. So here we go. We've got x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, let's plug the values in now. So we've got x equals negative, and b is negative 7, plus or minus the square root of negative 7, substituted in for b, minus 4 times a is 6, and c was negative 3. All divided by 2 times a is 6. Okay, negative 7 gives us a positive 7, plus or minus the square root of negative 7 squared is 49, and then we've got negative 24 times negative 3 gives us a positive 72. All over 2 times 6, 12. Okay, 7 plus or minus the square root of, do that calculation, and you get the square root of 121. Okay, and then our final answer would be 7 plus or minus the square root of 21 is 11 over 12. Now, remember, all throughout dealing with quadratics, we've usually had two answers for x, right? Usually that parabola crosses the x-axis twice. We can also have just one answer, or we can have 0 answers, but usually we have two. So that plus or minus there is going to give you two answers. So if we go to the next line here, this is still x is equal to 7 plus 11 is the first option, or 7 subtract 11. If we write that out doing the math, we've got the first value, 7 plus 11, would be 18 over 12. I notice that I'm going to have to reduce that, but I'll do that in the next step just to show everything. And 7 subtract 11 would give us negative 4 twelfths. Okay, that's not our final answer because it's not reduced. Let's reduce that. And our final answer would be 3 over 2. We divide 18 and 12 by 6, as well as negative 1/3. Those are our two values for x. And again, let's verify those. So we take those 3 over 2 and a negative 1/3 and put it into the original question. Now normally, of course, I would do this underneath, but it's hard to see the original question, so I'm going to scroll up and do it up here. So I had 6, and instead of x, I'm going to insert a 3 over 2, one of our possible answers, squared. Subtract 3 equals 7 times 3 divided by 2. 6 times 9/4, that's the squared. I did that multiplication there. I'd like you to keep going. I'm going to pause it and finish that calculation so I'm not wasting time on the video. So when I keep going here, I have 27 over 2 minus 6 over 2 equals 21 over 2. And yes, 27 minus 6 would be 21. So yes, this first x value, if I go down, this is verified to work. And negative 1/3, let's try that one. We've got 6, negative 1 over 3 squared minus 3 equals 7 times negative 1 over 3. Okay, I'm going to pause here. You can too do the math and check that out. And when I work that down, 2 over 3 minus 9 over 3 is negative 7 over 3. And yes, the two sides are equal, so yes, this last value for x has been verified. And here are our final answers using the quadratic formula to find those answers. Now, notice we could have solved this by typing this equation into decimals and finding the graph. We would get these exact same two x values for the x-intercepts. Or we could have looked at this trinomial. It is a not a simple trinomial. We would have had to use decomposition to factor here. I don't know if this was factorable. We didn't even check. But we could check what multiplies to negative 18 and adds to negative 7. Oh yeah, negative 9 and positive 2. We could have factored that to get our final answers. So any of those options will yield you the same answers. Flip the page. Example number 2, I'd like you to pause and try to do it on your own and see if your answer equals mine. Okay? Pause now. Okay, so we need to identify first the A, the B, and the C. We need to check if it's in standard form already before we can do that. So this is in standard form. A equals 5, B equals negative 10, C equals 3. Then we are going to plug that into the quadratic formula, which is x is equal to the negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Hopefully if you say that enough times as you write it down, that will be committed to your memory. Okay, now we're going to plug the values in. So, negative b was negative 10, plus or minus the square root of negative 10 squared minus 4 times a times c. It's all under the square root sign, all over 2 times a. Okay, and we've got positive 10 plus or minus the square root of 100 minus 20 times 3. 100 minus 60 should be the square root of 40, so I didn't need to make that square root sign quite so long. Okay, and all over 10, which equals 10. Now, do you remember how to simplify square roots? We're looking for a perfect square that's a factor of 40. So I'm going to show all the steps of my work. I realize that 4 times 10 is equal to 40. 4 is a perfect square. So I'm going to break those factors up inside there. And I'm running out of room. Okay, so 10 plus or minus. Now, the square root of 4 is 2. So take the square root of 4. We can't take the square root of 10. It is not a perfect square. It stays under the square root sign. Okay, so now we can just do one more step to reduce this. You see the greatest common factor in the numerator there is a 2. So we take a 2 out, and then 10 divided by 2 is 5, plus or minus 2 root 10 divided by 2 is root 10, all over 10. So now we can reduce this. A 2 and over 10 can be written, divide by 2, we get a 1, divide by 2, we get a 5. So our two final answers then, and we're going to leave the square root in the answer because that square root of 10 is a long decimal. We would rather have all those decimal values in there, so we leave it as the square root of 10. We could type that into our calculator and round off, but then it would not be an exact answer anymore. So we have our first answer of 5 plus root 10 over 5, and our second answer of 5 minus root 10 over 5. Now, you might find as you're doing your assignment that if the question does not ask for an exact answer, then in the back, this probably is figured out on your calculator and rounded off as asked in the question. Let's see. It says find an exact value. So we'll need to leave the square root signs in the answer. And that's our answer. Okay, move on to this last one. Okay, read through this problem and you can see that they've given us a quadratic equation right there. Read through it and then I'd like you to multiply it so it is in standard form. Okay, here's the answers in standard form. You'll notice that I factored out a negative 5 as their greatest common factor before identifying the A, B, and C. It makes your answer a lot, or the numbers you're working with a lot lower. Okay, stick these values into the quadratic formula. Notice right here we get a negative under the square root sign, therefore it's impossible. There are no real roots in this example, and no, the owners will not be able to increase the rental amount. Here's your assignment. Good luck.